As you can see, these are the homework problems from page 358, and the numbers that we're going to look at are on your screen or on the video. The focus of these particular problems in most cases is to anti-differentiate. Just as a reminder, the antiderivative of 1 over x dx, you need to know this to be successful, is the ln of the absolute value of x plus c. And the other fact that you need to know is that when you find the antiderivative of u prime over u du, you get ln absolute value of u plus c. So those are the primary focus of this particular homework set. So I'm going to get rid of those. And let's begin with number 1, doing the odd problems. Number 1, I don't really need to do any u substitution, so I can bring the coefficient of 5 on the outside by integral properties. And then the antiderivative of 1 over x is ln absolute value of x plus c. Start off with an easy one. Number 3, clear annotations. In problem number 3, since I have a denominator that is something other than x, now technically I can get away with not doing a u sub, but I'm going to show you the u sub. Eventually you'll be able to handle this. But the big idea here, I want you to focus on this, is that the coefficient of x is a positive 1. So when I take the derivative of that, it's just going to get me dx. So let me show you what I'm talking about. So in this case, I would let u equal to the denominator of x plus 1. The derivative of u is du, and the derivative of x is dx. So then that would become the antiderivative of 1 over u du, which is ln absolute value of u plus c. And that's going to turn into ln absolute value of x plus 1 plus c. So notice that the u substitution did a little bit. It helped me to get to the answer, of course, but because the coefficient of x is a positive 1, that's really what allowed me to not necessarily need the u substitution. But for now, go ahead and do the u substitution to make sense to you. Now in number 5, I am going to use u substitution because now the difference is the coefficient of x is not only 2, there is a negative or a minus in front of that. So in number 5, I'm going to let u equal to the denominator of 3 minus 2x. du is equal to negative 2 dx. When I use my math eyes to look, I know that there's not a negative 2 in the problem. So I'm going to divide both sides by negative 2. The coefficient of negative 1/2 goes in front. I get 1 over u du, which is negative 1/2 ln absolute value of u plus c. Make the resubstitution, and that gives me ln absolute value of 3 minus 2x plus c. That's number 5. In number 7, I have an x squared, so I certainly am going to need u substitution now. So when I see fractions, I generally begin by letting u equal to the denominator unless I can see a different strategy that makes more sense. Remember, all of these are strategies, and you are having to figure out what's the best strategy. The derivative of u is du. The derivative of x squared is 2x dx. When I look over at the problem, I do not see a coefficient of 2, so I'm going to divide it to the other side to get 1/2 du and then x dx. Good news, I see an x dx, so I can replace. That becomes 1/2 integral of, I lost my problem, 1 over u du. Notice the same thing's happening over and over again. 1/2 ln absolute value of u. Replace the u with x squared plus 1. Do I want to, in this case, you could actually drop the absolute values. I mean, you don't have to, but since we have x squared plus 1, regardless of the value we substitute for x and add 1, that would remain positive, but you don't have to drop them. I just want you to think about things like that. All right, that was number 7. Let's go on to number 9. Scroll the screen down here for just a second. Okay, so in number 9, I see a denominator, but I also see take apart. My denominator, my focus, folks, students, is the monomial denominator, monomial. So I can rewrite that as x squared over x. It's a take apart or Miss Oliver math. And that's going to become x minus 4 over x dx, which technically, if I want to keep breaking it down, is x, dx. I can take this apart using integral properties, bring the coefficient of 4 on the outside. I'm not going to use any u substitution because the antiderivative of x is x squared over 2. The antiderivative of 1 over x is ln, absolute value of x. Don't forget the c, and yes, you have to put the absolute value. So in number 9, keep in mind, we're looking for strategies. You have to examine each problem and make a good decision about what is the best way to pursue this particular problem. In number 11, I'm looking carefully at my numerator and denominator. My numerator power is 2. My denominator degree, I should say, is 3. So I have a larger power in the denominator. So since that's the case, I'm not thinking long division. I'm thinking u substitution. So I'm going to let u equal to the denominator of x squared plus 3x squared plus 9x. The derivative is 3x squared plus 6x plus 9. In the numerator, I don't see that, but if I divided both sides by 3, if I factored the 3 out and divided it to the other side, I would get x squared plus 2x plus 3. That's a good thing, because look, that's what I see right here with my math eyes. So my rewrite is the 1/3 coefficient out front, and then I'll have 1 over u, same thing every time, 1/3 ln, absolute value of u, plus c, and don't forget to substitute the original u. I'm not going to keep doing that because we've done enough u substitution now that you should be remembering that. Number 13, now I'm looking a little different, so I want you to compare number 11, which had a smaller power in the numerator, versus the larger degree in the denominator. In number 12, my larger degree is in the numerator. So there are a couple of things that I could think about doing here. I could think about long division, but before, remember, strategies, strategies, strategies. Before I think about long division, I'm going to try factoring the trinomial. So that'll be x and 2 and 1 and minus and minus. No, that can't be. It has to be. Let's fix that. Has to be. Yeah, minus and minus. So minus 2, minus 3. But that x minus 1 doesn't divide with the x plus 1. So factoring was not the best strategy. It's all about strategies and thinking about things that you can mathematically do. It's going into your toolbox and trying things. So since that did not work, I'm going to do the long division. Pay very close attention to the long division. So I have x squared minus 3x plus 2. So I look at the x and I look at the x squared, and over here I ask x multiplied by what will give me x squared, and I know the answer is x, and I'm going to put that x over the x. It's sort of like place value. I'm going to multiply the x by both of these terms, so x times 1 is x, positive, and x times x is x squared, and that's positive. Think about your normal division 4th grade algorithm. You divide, multiply, and then subtract the whole thing. This could be what really messes you up. X squared minus x squared they're going to knock each other out. Careful right here. Minus 3x minus x gives me negative 4x, and then the next step of division in the 4th grade is bring down. I'm going to start the game again. I'm going to take my divisor. I'm going to worry about the x. Multiplied by what will give me negative 4x. Of course, that's negative 4. Whoops, I meant to put that in red. There we go. And now I'm going to multiply negative 4 times 1 and get negative 4. I'm getting ready to sneeze, so I paused the video just in time to sneeze. Negative 4 times x is negative 4x. Here's the danger zone. you got to subtract the whole thing. And that looks like a similarity symbol, but it's minus. So negative 4x minus negative 4x knock each other out. 2 minus negative 4 is 6. So that is my remainder. So what I've now done is I've said this quotient is equal to x minus 4, that's the quotient, plus, remember your 4th grade math, you take the quotient, the remainder, over the divisor. Okay, so this is the quotient that I got. This is my remainder. This is my divisor. So that's true. It's based on your 4th grade understanding of fractions. So I have the integral of x minus 4. I'm going to separate these using my integral properties. I'm going to bring the coefficient of 6 on the outside to be 1 over x plus 1 dx. My integration of x is simply x squared over 2. My integration of 4 is minus 4x. Now remember we did this one earlier. The coefficient of x is 1, and there's nothing else but just x to the 1st power plus 1. Go back to problem number, I think it was the 2nd one that we did. Yes, if you look back at problem number 3, you can go through the u substitution and let u equal to x plus 1 and follow that through, just like I did in number 3. And what that's going to give me is 6 times the ln absolute value of x plus 1. Don't forget the c. Okay, so there's your example of long division. Practice it, do it. Don't just watch me do it. Make sure you do it. All right, that brings us up to number 13, which is another long division problem. So since long division gives a lot of students trouble, I'm going to do the long division again. So x plus 1. Make sure you do it first and then resume the video. X squared minus 3x plus 2. Now I didn't think about factoring again. Did I do this one already? Did I do 13 instead of 11? Seems like I did. That's interesting. Oh, no. That I was sorry. I'm back. I did 11. I did 13. I better do that. In number 15, yes, back in the ball game. I'm glad I didn't do that problem again. I would have been mad. In problem number 15, the degree in the numerator is greater. So yes, I am going to do the long division. And watch me carefully here. I have x cubed minus 3x squared. Now, because there is no x, I'm going to put in a 0x, which serves as a placeholder. So I have the 3rd degree, 3rd power, 2nd power, 1st power. I start the game, I take the x, and I ask myself x multiplied by what is equal to x cubed. That is x squared, so it goes over the x squared term. Then I multiply x squared times negative 3 is negative 3x squared. X squared times x is x cubed, which is exactly what we wanted. We're going to subtract the whole thing. The x cubed subtract. Negative 3x squared goes slow. Plus 3x squared, that goes as well. I can bring down the 0x, but I don't really need to in this case, so I'm going to bring down the 5, and I have my answer. That is my remainder, because x times, I'm not going to ask myself x times what makes 5. So the quotient is x squared, the remainder is 5. So this integral, number 15, is equal to the antiderivative of x squared dx plus, because remember it's x squared plus 5 over the divisor. So 5 on the outside, 1 over x minus 3 dx. The antiderivative of x squared is x cubed plus, there's my 5 coefficient. Same thing that we had before. The coefficient of x is 1. So I know that that's going to give me ln, absolute value of x minus 3 plus c. But you can do the u substitution. It's totally fine. Okay, let's go on to number 17. The degree in the numerator is greater than the degree in the denominator. So it's looking like a long division again. So I'm going to have, now watch carefully, x squared plus 0x plus 2. So I include all the degrees, all the powers. X to the fourth plus 0x cubed plus 0x squared plus x minus 4. So we have x squared multiplied by what gives me x to the fourth, and that is x squared, which goes over x squared. Multiply all three terms, and that's going to give me plus 2x squared, 0x cubed, and x to the fourth power. Subtract. Out, 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 and that'll give me minus 2x squared, bring down plus x, and since this is a trinomial, I'm going to go ahead and bring down the minus 4, because I will ask myself x squared multiplied by what is equal to negative 2x squared, and that is negative 2, so minus 2. Sorry, I didn't mean to put that dot right there. That's just a stray mark. All right, so that's just x minus 2. I just like to keep my place value. All right, so there we go. All right, so I'm going to multiply the negative 2 by each term, so that makes 2 times negative 2 is negative 4. Negative 2 times 0x is 0x. Negative 2 times x squared is negative 2x squared. Subtract the whole thing. Subtract. Out, out. That's going to be x. And negative 4 minus, or plus 4 is 0. So our new expression is x squared minus 2, that's the quotient, plus the remainder of x over the divisor, x squared plus 2. So I'm going to integrate x squared minus 2 by itself, and then I'm going to integrate x over x squared plus 2 by itself. For the integration of x squared, I simply get x cubed over 3, and the integration of 2 is 2x. For this, I'm going to do a u sub, so you have to treat each term that you encounter as it needs to be. So I'm going to let u equal to the denominator of x squared plus 2, take the derivative and get 2x dx. I don't need that 2, it's not in my term that I'm looking at right here. That gives me x dx. So the rewrite of term number 2 would be 1/2 1 over u du, there it is, 1/2 ln, absolute value of u, plus c. Take it back to my problem, and that'll be plus 1/2 ln, replace, x squared plus 2, plus c. All right. All right, let's get to number 21. Number 19. In number 19, I have an inside function of ln x. So this time I'm not letting u equal to the denominator. You got to use whatever strategy you need. We're looking for inside functions for u sub. The derivative of ln of x is 1 over x dx. That's a good thing because that's what I have. I'm going to rewrite my new integrals, so I'm substituting u in place of ln x, so that becomes u squared du, oh that's easy, and I get u cubed over 3 plus c. So that means that when I make my replacement, I will get ln of x to the third power over 3 plus c. Number 21, I see an inside function of x plus 1, so I'm going to let u equal to x plus 1. du is going to be equal to dx. I'm going to make my replacement. That's going to become 1 over u to the 1/2 power du, which is the integral of u to the negative 1/2 power du. And I'm going to increase the power by 1, divide by the power, and put a plus c. I'm going to resubstitute and make that 2 x plus 1 to the 1/2 power plus c. 23. Let's see. I'm going to let, what am I going to let? I think I'm going to let u equal to x minus 1, because that's an inside function. So 23 u is equal to x minus 1. du is equal to dx. So if I replace, I can take that coefficient of 2 on the outside. It looks like stubborn x has reared its ugly head right there because I don't have a replacement over here in my key. So I can replace or substitute in the denominator. I can make that u squared. So remember, now we're going to take this and we're going to get x by itself and make that u plus 1 equal to x. So now that x, even though it's stubborn, I found a way around it, I can substitute and make that u plus 1 du. I can break apart Miss Oliver math and make that u over u squared is going to be u. Let's fix that, make that better. Come on, you can do it. Oh, no pun intended, you can do it. Did you get that? I just got it. So u over u squared plus u to the negative 2. There's a reason I'm writing them. I'm preparing for what is going to happen. That becomes 1 over u. That's how I want to see. I want to see the 1 over u as 1 over u versus u to the negative 1, which I might do something silly with. So that gives me 2 ln absolute value of u. And now power rule, increase the power by 1. So that becomes u to the negative 1 divided by negative 1 plus c. So resubstitute 2 ln absolute value x minus 1 minus 1 over x minus 1. Or you could keep it in the numerator and make it parentheses x minus 1 to the negative 1. So that's 1 through 23 odd.